This is Michelle Cullen. Join me on an overview of dwarf planets, comets, and the far reaches of the solar system. And this is Astronomy 103 for Prince William Sound College in beautiful Valdez, Alaska. Module 8 is on dwarf planets, comets, the Kuiper Belt, and beyond. So let's start out by revisiting the definition of a planet versus dwarf planet. This is really important when the topic of Pluto comes up. You want to be able to say why Pluto's no longer the ninth planet. It was 2006, the International Astronomical Unit stated that a planet is a body that one orbits the sun, remember they all orbit in the same direction, and that it's massive enough for its own gravity to make it round, and it's cleared the neighborhood of smaller objects around its orbit. Poor Pluto, no longer a planet, got demoted. The reason why it was demoted is because there were some newly discovered other potential planets, planetoids, trans-Neptunian objects that were in the neighborhood beyond Neptune there. Those small bodies were discovered in the early 2000s, and so by the time 2006 came along, the definition was changed. Pluto, you're out. We don't have 15 new planets or 20. There are not going to be hundreds of planets in our solar system. There'll be eight that have cleared their neighborhood, that are traveling around the sun. And the rest are going to be either dwarf planets or minor planets. I want you, though, in your conversations with your friends and families, to be able to defend the clearing the neighborhood rule. What does that really mean? Well, it means that if an object's a planet, the gravity was able to be enough to either capture anything and make it a moon, like Neptune has moons and Saturn. That's one way to clear the neighborhood. Another way is just to cause whatever's in your path to be crashed into your surface. That's another way. Or another way would be to use your gravity just to draw something in and sling it away. Remember all those Jovian moons we looked at? They're about the same size as dwarf planets. Some of them were probably created at the same time near Pluto, and they were just captured. Like Triton is a perfect example of that. It's probably a trans-Neptunian object that got captured by Neptune. Let's look at our 5 official dwarf planets and know that there are other candidates. The 5 are Ceres, Pluto, Eris, Haumea, and Makemake. Expect more to be included in the future. And the candidates are Sedna, Quaoar, and even the object Didi, a new one that might be. And of course, I am sure there are more out there ready to be discovered. Let's look at dwarf planet Ceres, the closest one to Earth. Discovered in 1801, the largest object in the asteroid belt. Ceres recently has been made popular by the fantasy science fiction series on Netflix, Beyond. Ceres may be the largest asteroid, but it's 14 times less massive than Pluto. Some interesting things we know from a mission, the Dawn spacecraft that flew by, it discovered that Ceres has water vapor spewing from its surface. It also has a volcanic ice dome known as Oort Mons, and it's 4 kilometers high. And Ceres is just an interesting planet. It might be rich in metals that make it economically viable to be colonized in the future. We just need to go there and find out. We need to land on it. Okay, Pluto, the underdog, the poor demoted Pluto, and well loved. It was discovered in 1930 and named the 9th planet, and now we know 2006 reclassified. New Horizons mission flew by in 2015 and has revealed so many exciting discoveries about Pluto. And I hope you have a chance to look them up, look on your textbook, read in all sorts of publications in NASA. You're going to learn about its young surface, geologically active, very few craters. It has high mountains. There's all sorts of, it's very, very cold. There's frozen methane, nitrogen, and frozen water. There's even glaciers There's red snow. It's very strange. And it also has a bluish atmosphere. We got a close-up look at the 5 moons orbiting Pluto, and the largest of those is the moon Charon, and it's almost the same size as Pluto. So that makes it almost a binary dwarf planet, as Charon and Pluto do a little do-si-do dance around each other. But Pluto is a little different than the other regular planets in our system. We call it a bit of an odd dog. It has an orbital path that doesn't quite lie on the same plane as the 8 planets. It's inclined to an angle of 17 degrees, and its orbit is also more oval shaped or elliptical than those of the other planets. So it actually crosses into the orbit of Neptune. And we'll see that it has other dwarf planets that cross its orbit, like Eris. It has a very highly elliptical orbit that takes it deep into the Kuiper belt. We've got, besides Eris, we have Haumea, and it spins so rapidly that it actually couldn't keep itself round. Remember one of the other definitions of a major planet. And it has a sort of cigar shape, and it has a 4-hour day. It just spins quickly. And again, we've got a large, the last official one is Makemake, and it is the size of, just about the size of Pluto, and it's beautiful too. Here's some other candidates you can see, and they're all different sizes and sometimes a little different shape. And we'll be seeing which ones make the grade as dwarf planets, or if they'll change the name and we'll have lots of planets. I'm kind of secretly hoping for that. We also learned about comets this module and their general characteristics. Well, comets inspire awe. When we look in the night sky, and if you've ever seen one, you'll know what I mean. I met my future husband at a star party observing Halley's Comet in 1986. As historic as Halley's Comet was, it was just looking a little bit like a star in the sky. It took binoculars to actually see that it was a comet. I was more impressed with the comet Hale-Bopp, and many of you may have seen that. It was visible in the Alaskan sky in North America in 1997. And Hale-Bopp had the distinct visible trail of a classic comet glowing in the night sky. It was visible for over 18 months from the planet Earth. And it was just incredible for all of you who saw it. Comets are, what are they? Well, they're leftover icy bodies. They reside in the outer region of our solar system. And they can come from 2 areas. The Kuiper belt, which extends on the plane of the disk beyond Neptune. And they also can come from the whole spherical shell called the Oort Cloud. Here you can see the Oort Cloud is immense compared to the small area in the center of the Oort Cloud, which is our proper solar system with our planets and dwarf planets and Kuiper belt in the center there. And the Oort Cloud can go out millions of kilometers and up to a light year from the sun. It's easy to study comets because they come to us. They head into the inner solar system once in a while. One will get nudged by maybe some passing dark matter or the interaction of 2 of them hitting each other. For some reason, one of them will start its journey towards the center of the solar system. NASA had a program called the Stardust Mission, and it went out and actually captured the dust. And they found, of course, water vapor. We found there were a complex amino acid, glycine. Comets may be resources for future space mining corporations. And they also could be a threat to Earth. So these are compelling reasons why we need to study comets in more detail. Wait, there's actually more that comets are teaching us. The very first interstellar comet, 2I Comet Borisov, was discovered by an amateur astronomer on August 30th, 2019. 2I stands for interstellar. It comes from beyond our solar system. As I record this, the comet is coming close to the sun. It will be the closest on December 7th, and then later in December, it will be less than 2 astronomical units away from Earth. This comet Borisov has a nucleus that's fairly small, 1.6 kilometers across, and right now it's having an enormous tail of icy debris and dust and rocks that are extending 1,600 kilometers beyond it. And here's an image that shows that the tail is 14 times larger than the diameter of the Earth. The Coma is an area that's bright and glowing that has ionized gas, and actually there are two tails. Comets, as they approach the sun, will have a tail that's the melting ice and dust, and then it will have a tail that's caused by the solar wind streaming past it, and it will have an ionized gas tail that is caused by the solar wind. And it will stream sometimes in a different direction depending on the angle of approach to the sun. The solar wind will blow the tail in one direction, and the rest of the material will be just streaming out behind it as it goes forward, much like a wake on a boat. So we see that Comet Borisov has all of the classic parts. We can learn about Comet Borisov with spectroscopy, and we found that it's in other ways similar. It has water vapor, and they've discovered cyanide gas, which is common in our solar system comets, and there's some carbon too. So we're learning what this interstellar visitor can tell us about distant solar systems and comets that are formed there. The historic Rosetta mission is an important history in astronomy, and I just want you to be familiar with it. This comet was P67. It's a quick orbiting, so it made a quick return by 2014 in time for the Rosetta mission to visit it. And they were able to match the comet's orbit and trajectory, and they were able to send the little Philae, which was a lander, and it got close to the surface, bounced a few times, and did settle down on the comet, transmitting data. So this was a first. Unfortunately, it landed in a dark hollow, and the power went out when it couldn't get sun for its solar panels. So the Rosetta followed it along from 2014 to September of 2016, when they decided to crash Rosetta Orbiter into the rubber duck-shaped P67 comet. And when they found that the comet was rockier than they expected, so instead of like being a dirty snowball, they called it a snowy dust ball. Let's look at a group of objects that the book talks about. Our OpenStax Astronomy talks about a group of centaurs that also show that this line is blurred between what is a comet and what is an asteroid. Icy and rocky, and they orbit around just outside of the J and the N, the Jupiter and the Neptune. They sort of show that actually these planets haven't really cleared their neighborhood, but because there's all these centaurs going around in the same orbital paths as the planets Jupiter and Saturn, Uranus, and Neptune. Busy place in the outer solar system. And there's really much more we need to learn, and with time and more missions, we will learn the secrets of our solar system, and as we hopefully will find more interstellar comets, we'll learn more about other solar systems too. It's a good time to be an astronomer. I hope you think of this as you think about your career path, and you also might think about just being an amateur astronomer, because it was an amateur astronomer that discovered the Borisov interstellar comet. I hope that you enjoy this unit and keep your eyes up in the sky and be full of wonder in the universe.